It was -40 outside. The wind was screaming. The snow was horizontal, being swallowed by the same blizzard that he was completely ignoring. A wood stove blazing 3 feet away while the storm tried and failed to touch him. The old log cabin behind him through that enormous arch window, buried, crumbling. That image tells you everything you need to know about what is happening quietly across Alaska right now. Smart men are walking away from traditional cabins, not because they hate them, not because they ran out of money, but because they found something better, something faster to build, something cheaper to heat, something that laughs at permafrost, shrugs off ice dams, and holds up under snow loads that would fold a standard roof like a piece of wet cardboard. And most people have never even heard of it. Stay with me, because by the end of this video, you're going to understand exactly why the Quonset hut is the most underrated structure in cold weather survival living, and why the men building them are sleeping warmer, spending less, and living better than anyone still fighting their traditional cabin every single winter. Let's start with the problem, because if you have never lived in Alaska or anywhere with truly brutal winters, you might not understand how completely a traditional cabin can work against you. Picture a standard gabled roof. 2 flat planes meeting at a peak. Looks great in a magazine. Performs terribly in a blizzard. Snow lands on those flat surfaces, and it stays there. It builds, and builds, and builds, until you are dealing with hundreds of pounds, sometimes thousands of pounds, of pure dead weight pressing straight down on your structure. Ice dams form at the eaves where heat escapes through your poorly insulated roof deck. Water backs up under your shingles. It finds every gap, every nail hole, every seam. Then it freezes. Then it expands. Then it destroys. That is not a worst-case scenario. That is a Tuesday in Alaska. And the heating, a traditional rectangular cabin, is essentially a box designed to lose heat from every corner. Cold air infiltrates at the foundation. It sneaks through wall penetrations. It escapes through the attic because heat rises, and a square building gives it every opportunity to climb straight out through the top. You burn through propane at a rate that makes grown men cry when the bill arrives. You stack firewood all summer just to survive the winter. And even then, even with all that, you wake up at 3 in the morning and the fire has dropped and you can see your breath inside your own home. That is the life that tens of thousands of Alaskans have been accepting as normal. Not because it is acceptable, but because they did not know there was a better way. The Quonset hut has been around since 1941. The United States military needed a structure that could be shipped flat, assembled fast by soldiers with no construction experience, and survive in every climate on Earth, from the South Pacific to the Arctic. What the engineers at Quonset Point Naval Air Station in Rhode Island designed was a half-cylinder, a steel arch, no corners, no flat roof planes, just one continuous curved surface that starts at the ground, sweeps overhead, and comes back down the other side. The military built over 150,000 of them during World War II. They went up in hours. They survived conditions that destroyed conventional buildings. Soldiers slept in them in the Pacific. Mechanics worked in them in Iceland. They housed field hospitals, mess halls, and command centers on every front of the war. And when the conflict ended, the design did not disappear. It evolved. Today's Quonset hut is not a corrugated metal shed with a dirt floor. That is the misunderstanding that stops most people from ever seriously looking at them. Modern Quonset structures use galvanized steel arches, pre-engineered, pre-punched, shipped flat on a truck, that bolt together on site without heavy equipment, without a crane, and without a crew of 20 specialists. 2 men with basic mechanical ability can assemble the shell of a Quonset in a matter of days, not weeks, days. And that shell, that single curved surface, solves almost every problem that a traditional Alaskan cabin creates. Start with the snow. A curved roof does not hold snow the way a flat plane does. Physics takes over. The arch redirects the load. Snow hits the curved surface and slides. The structural integrity of an arch under compression is one of the most powerful geometries in all of engineering. The Romans figured this out 2,000 years ago when they started building aqueducts, and the principles have not changed. A properly designed Quonset arch can handle snow loads that would collapse a conventional truss roof. This is not a small advantage in a place where snowfall is measured in feet, not inches. Now think about ice dams. Ice dams form when heat escapes through your roof, melts the snow at the peak, and that water runs down to the cold eaves and refreezes. The condition requires two things: a differential in roof temperature and a flat or low slope surface for the water to travel across. A properly insulated Quonset arch eliminates the temperature differential, and the geometry of the curve means that any water that does form moves immediately. It has nowhere to pool, nowhere to sit, nowhere to back up. The ice dam problem essentially disappears. This is where a lot of people stop and say, okay, but what about insulation? How do you insulate a curved metal surface? The answer is spray foam, and it works better on a Quonset than on almost any other structure. Closed-cell spray foam adheres directly to the interior steel surface, fills every gap, creates a continuous thermal and vapor barrier, and adds structural rigidity to the arch at the same time. There are no corners where insulation sags, no stud bays where it settles and leaves cold spots, no penetrations that create thermal bridges. You spray the interior of the arch and you have created one of the most airtight, thermally efficient envelopes possible in a cold weather building. And here's the part that most people never think about. The interior volume of a Quonset hut is fundamentally different from a rectangular cabin of the same footprint. In a rectangular cabin, you are heating a cube. Every inch of that volume, floor to ceiling, wall to wall, has to be brought up to temperature. In a Quonset, the walls curve inward as they rise. The livable space is concentrated at the center and near the floor, exactly where you and your dog and your wood stove actually are. The dead air volume up in the peak of the arch acts as a natural thermal buffer. You are not fighting to heat space you will never occupy. The geometry works in your favor. A well-insulated Quonset hut can cut your heating costs by 30 to 50% compared to a traditional cabin of similar floor area. That is not a marketing claim. That is a lived experience of the men who have made the switch and are now burning half the firewood and spending a fraction on propane, compared to what they were hemorrhaging in their old rectangular boxes. Now here is something that almost nobody talks about when they discuss Alaskan construction, and it might be the most important factor of all: permafrost. Alaska sits on top of it across enormous portions of the state. Permafrost is exactly what it sounds like: ground that is permanently frozen, sometimes to depths of hundreds of feet. And for decades, builders treated it like solid ground. They poured conventional concrete foundations on top of it. They set posts into it. They built heavy structures on it. And for a while, sometimes years, sometimes decades, everything looked fine. Then the permafrost shifted, or thawed slightly around the heat source of the building, and the foundation moved. One corner dropped, a wall cracked, the door frame racked, and the door stopped closing. The logs shifted, and the chinking fell out, and the cold poured in. Traditional cabins in Alaska are not just fighting the weather above ground. They are fighting the ground itself from below. A Quonset hut changes the equation in two critical ways. First, it is dramatically lighter than a log structure. A traditional log cabin can weigh tens of thousands of pounds in structure alone before you add any contents, snow load, or equipment. A steel Quonset arch system for a similarly sized structure weighs a fraction of that. Less weight means less pressure on the permafrost. Less pressure means less deformation. Second, the foundation options for a Quonset are inherently flexible. Helical piers, essentially giant steel screws driven into ground, can be adjusted as the ground shifts. A properly designed Quonset on helical piers can accommodate ground movement that would destroy a conventional foundation. You can actually go back and re-level the structure without rebuilding it from scratch. The combination of low weight and flexible foundation options makes the Quonset one of the most permafrost-compatible structures ever designed for residential use in extreme cold climates. The men who understand this are not switching to Quonsets because they are cheap. They are switching because they are smart. Let's talk about cost and construction, because this is where the numbers start to become genuinely shocking. A traditional Alaskan log cabin, properly built, properly chinked, properly insulated, runs somewhere between $200 and $400 per square foot in most remote areas of the state when you factor in labor, materials, and logistics. In remote locations where everything has to be flown in or barged, that number climbs higher. The skilled tradesmen required Framers, log workers, insulation contractors, roofers are expensive, hard to schedule, and often have to be housed on site at additional cost. A project that should take a summer can easily bleed into 2 or 3 seasons. A Quonset kit, the pre-engineered steel arches, end walls, and hardware, ships on a flatbed truck for a structure in the 1,000 to 1,500 square foot range. You are looking at kit costs that run dramatically below conventional framing materials for the same footprint, often by 40 to 60%. The assembly requires no specialized skills. The instructions are engineered for 2 men with basic tools. You do not need a framing crew. You do not need a log specialist. You need time, basic mechanical aptitude, and the willingness to actually read the manual. The total all-in cost for a finished insulated livable Quonset in Alaska, including foundation, spray foam insulation, a simple end wall system with doors and windows, and interior finishing, comes in at roughly half to 2/3 the cost of a comparable traditional cabin in the same location. That is a difference that, for many men, is the difference between building something and not building anything at all. Now, the objection, the one that comes up every single time this conversation happens. They look industrial. They look like warehouses. No one wants to live in a tin can. Look at that image again. Really look at it. The warm, honey-colored pine paneling running up the interior of that arch. The Edison bulb string lights draped across the ceiling in a warm amber glow. The cast ironwood stove sitting on its hearth, glass front glowing orange, stacked firewood beside it. The enormous arched window framing the snowstorm outside like a living painting. The man inside, warm, barefoot, completely at ease, his dog sleeping on his chest. That is a Quonset hut interior. That is what happens when someone takes a structural shell, which is just geometry and steel, and finishes it like a home instead of a warehouse. The arch is not a limitation. The arch is a design feature. It is what makes every interior photograph of a Quonset look like something from an architecture magazine instead of a construction site. The curve draws the eye upward. It creates a sense of volume and openness that a rectangular room with a flat ceiling can never achieve. It is, paradoxically, one of the most naturally beautiful interior shapes in residential construction, and it costs less than the boring box it replaces. The practical interior challenges are real but solvable. Curved walls mean standard rectangular furniture sits away from the wall on the sides. The solution is simple. Keep furniture central. Use floating shelves that follow the curve, or, as many Quonset builders do, frame a partial straight interior wall on the lower side of the arch, giving yourself a flat surface for cabinets, shelving, and storage while preserving the dramatic open curve overhead. Custom curved shelving, when done well, becomes a design statement rather than a compromise. Condensation management requires attention. Metal conducts cold, and if your spray foam insulation is not continuous and properly applied, you will get condensation on the interior steel surface. The solution is a proper vapor barrier combined with closed cell foam at full recommended thickness, typically 2 to 3 inches minimum in Alaskan conditions, more in extreme cold zones. Get the insulation right, and condensation is not an issue. Skip corners on the insulation, and you will pay for it. Acoustics in heavy rain or hail can be noisy on an uninsulated metal shell. Once the spray foam is applied and an interior finish layer is added, whether that is wood paneling, drywall, or rigid board, the acoustic performance improves dramatically. Most Quonset owners report that after finishing, the interior is quieter than they expected. Permitting varies by municipality. In remote Alaska, many areas have minimal or no permit requirements for residential structures under a certain square footage. In organized boroughs, you will want to check local codes, not because Quonsets fail to meet structural requirements, but because some jurisdictions have appearance codes or zoning restrictions that were written when the only residential buildings anyone imagined were rectangular. This is changing as off-grid and remote living grows in popularity, but do your homework before you break ground. Here's the truth about what is actually happening across Alaska right now. A quiet shift is underway. It is not loud. It is not on the front page of any newspaper. It is happening one build at a time, on remote lots and off-grid properties, among men who did their research, ran their numbers, and decided that fighting the same losing battle with a traditional cabin every winter was no longer worth it. These are not men who gave up on quality. They are men who found a smarter definition of it. They are sleeping through blizzards that used to keep them up managing a dying fire. They are cutting their heating bills in half and spending that money on something other than propane. They are building on ground that would have swallowed a conventional foundation without blinking. And they're doing it faster, cheaper, and with more structural confidence than the men still swinging hammers at conventional log walls. The old cabin in that photograph, the one visible through the arched window, sitting in the blizzard, covered in snow, looking exactly as cold and difficult and expensive as it really is not a backdrop. It is a before picture. The Quonset hut, looking out at it, is the after. The arch sheds of snow. The steel holds under the load. The spray foam locks the heat inside. The helical piers move with the ground instead of fighting it. And somewhere inside, on a camp cot, a man is warm. His dog is warm. And the storm that is destroying winter after winter for everyone else in the traditional cabin is doing absolutely nothing to them. That is not luck. That is engineering. That is geometry. That is what happens when you stop building the way people have always built in Alaska, just because that is how people have always built in Alaska, and you start asking whether there is a better answer. There is. It has been sitting in plain sight since 1941, and the smartest men in the state are finally paying attention.